Hello class, this is a video tutorial on a probability tree example. Probability trees are best used for problems with two or more stages or events. It's also best used for when each event has limited outcomes for each of the stages or each of the events. So for example, it's not recommended, and big emphasis on recommended, because you still can use it, but not recommended, for dice rolls, as each stage will have so many outcomes or branches. So for example, stage 1 or event 1 are the coins, which is okay because there's only 2 of them. But notice how when we try and draw the branches for the stage 2 or the event 2, which is the die, we have 6 branches for each of the previous branches. Notice how this can get very large very quick if we add another stage or another event, and hopefully it's not another dice. So let's get straight to an example here. 3 coins are thrown. Calculate the probability of 3 heads, 2 tails, no heads, and at least 1 heads. Now you can pause the video and give it a go in creating a probability tree that simulates this particular problem. I'm going to be drawing it in 3, 2, 1. Here we go. For this, we should recall the end branches first. And we can figure out how many branches there will be at the end by using what we know about independent events. So 3 coins are independent of each other, because if you throw one, it will not affect the result of the other. So the total sample space, or the total number of outcomes, is 2 in the first coin times 2 in the second coin times 2 in the third coin, which is a total of 8 total branches. So working from the right, we will have heads or tails, and we'll just repeat that actually. So that's 2, that's 4. If we double this again, that's 8. So this is the third coin. So we'll call this coin 3. So C3. Now the second coin, well, it's also heads or tails. But from this, we can branch to heads and to tails. The second coin could also be tails, which also branches off to heads or tails. And this will repeat for all of them, like so. So notice how it's 8, 4, the last one will be 2. So for coin 1, it could also be heads or tails, like so. This is the beginning. And there we have a probability tree for 3 coins being thrown. Let's write out all the probabilities. This isn't a must that you have to do. It just helps for later on. So 3 heads, 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 tails. And how I'm writing these is just I'm looking at the branches it took to get there. So heads, 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 3 heads. Oops. This one, it's heads, heads, tails. So H, H, T. This one here is heads, tails, heads, and so on. So heads, tails, heads, heads, tails, 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 heads, heads, tails, tails, heads, tails, tails, tails. Make this a different color so we don't get confused from the other one there. And there we have it. Now we could also find the probability of these, which is nice and easy because this is 1/2 for everything here. So if we were to multiply every single probability, so heads is a half, times heads is another half, times heads is also a half. So this is 1 in 8. This is the same for everything here. So everything here will have a 1 in 8 chance of occurring. But now the difficulty comes in interpreting this question itself. So the probability of 3 heads, that's the probability of heads, 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 which is 1 in 8. The probability of 2 tails, let's count out the ones that have exactly 2 tails. That's 1 in 8. And the other 2 tails, is there another one here? Tails, oh, there it is. Heads, tails, tails. That's also 1 in 8. So that's probability of tails, tails, heads, plus the probability of heads, tails, tails. 1 in 8 plus 1 in 8. That gives us 2 in 8. The probability of no heads at all. Well, that's the same as the probability of 3 tails. Well, that's going to be this one here. That's 1 in 8. Let's erase these. That's 1 in 8. Probability of at least 1 heads. This one often confuses students quite frequently. They often mistake this as exactly 1 heads. But remember, at least 1 heads means you could have 1 heads or 2 heads, 2H, or 3 heads. So really, the only thing that we don't need to count is no heads. So this is actually the same as 1 minus the probability of 0 heads, so 0H, or 1 minus probability of 3 tails, which is what we've already calculated. That's 1 minus 1 in 8, which gives us 7 in 8. We could also have counted all of these. So notice how this is 1 heads, 1 heads, 2 heads, 1 heads, 2 heads, 2 heads, 3 heads. All of these that we've circled, that's 1, 2, 3, 4, 5, 6, and 7. 7 lots of 1 in 8. So 7 in 8. This one example has gone longer than I expected. So I hope that gave you an insight with one example. I'll be doing one more example using the same page with one that's slightly more tricky. Hope to see you then.